will be related to SQL part. So we will not using the IntelliJ anymore. We will use the, let me, 1 second. So, okay, let me resume sharing. So in the next part, we will using this Oracle LiveSQL, and also you can maybe create your own account. This is for free using. So let me introduce about the basic concept in the SQL database. So first, for the database, we need for the SQL database to have at least have a database, right? So this schema is the same meaning as a database. So in the live SQL, you will have multiple database, and for today, for our session today and in the future, let's just use the human resource database for illustration. And you can see those are the tables in the SQL, in this HR SQL database. So for the two most fundamental elements for the SQL, for the database is the schema and the table. And the schema is the same words as database. So let me write something down here. So first, let us come up with some different types of database, like including NoSQL database, like just all kind of database. So does anyone ever can provide some answers to like what database you ever used previously? Like, have you guys ever used any database like SQL or NoSQL or even file system? All of them are good. Yeah, MySQL. Yeah, that's good. Like those are the yes. So yeah, MySQL and SQLite. How about also SQLite? Yeah, those are some um, RDBMS, like the relational database. And any other things? Yeah, PostgreSQL. Yeah, that's one. That's also one SQL database. PostgreSQL. And also any other things or NoSQL database, things like that. Have you guys ever used any other answers? Like MongoDB. Yeah, MongoDB is one NoSQL database. And also, yep, DynamoDB. DynamoDB are DynamoDB is like a database provided by the AWS, right? Remember. And also maybe for the RDBMS, maybe you have ever also heard about like the SQL Server, things like that. Those are all kinds of SQL database. And also I forgot the name of that AWS provide to us. Like it allow us to select the database engine, the SQL database engine, and then it will manage the database for us. I think called AWS RDS, right? You can use the RDS to let AWS to manage the database for you, but you can select the underlying database engine, like whether MySQL, PostgreSQL, or Oracle DB, or PostgreSQL, just whatever SQL Server, whatever database engine that you prefer. And also for NoSQL, there are like MongoDB and also something called Cassandra. Those are most commonly seen NoSQL database. And so when we try to explain the CAP theorem, we'll use this two database as an example to explain that what is CAP theorem, that the consistency, availability, and partition tolerance. And also there are other NoSQL database like the in-memory database, a NoSQL database called Redis. That is the in-memory the NoSQL database. It has a like fast access time, but you can. I think it also supports the persistency. Like you can also persist the data in the memory into a disk by using Redis. But I forgot the detail, but I believe we can. Otherwise, if we do not have the durability for the database, I think it cannot be called as a database. So also we can have something like called Elasticsearch. Some of the um, some of the article may be categorized into a NoSQL database, but actually the Elasticsearch will be more like a search engine. So, but you can still store some data into it, but it's more like a search engine. But like the nowadays, more like those products, their functionality are kind of wide. So the definition for to make them to make a definition for them is kind of become blurred. That's because their functionality are kind of cross to each other. Like the even for the Elasticsearch, it's a search engine, but it provides you a way to store the data. Like their functionality is kind of grow stronger. Like compared to like maybe the old days, the each software just focus on one aspect, but nowadays they are adding new features, adding more functionalities, so they are kind of overlapping. And also, there are file system like the Amazon S3, right? You will also use it like a database. You just store the files into the S3 buckets, but it's more like a file system, store the files. But actually files are also data, right? So you can still consider it to be a database. So yeah, those are some database that maybe we will meet in the real life. And today, let's just focus on the relational database. So does anyone know like any important or essential features in relational database, or to develop a relational database, what we need? So this is also like the feature in RDBMS. Any answer to this? Like what we need to develop a database, or any feature? Yeah, ACID principles. That is a good answer. Like ACID. And does anyone know like what is ACID principles? Like each word stands for what? Like A maybe atomic, right? And C is like consistency, right? And I is the isolation level, and D is the durability. Like A means all of your queries in one transaction. Actually, the ACID is the property of the transaction, right? Transaction. So in one transaction, it will contains many queries, and all of those queries will be considered as one entity. So that is called atomicity, atomic. And also the consistency. Like this consistency actually is the definition for the consistency in ACID is different to the consistency terminology in the CAP theorem. So this consistency, because our relational database actually, most of the cases not like the NoSQL database that you need to consider about the data consistency between each nodes. This consistency in transaction means the stage of the database, relational database, will move from one valid stage to another valid stage. Like the dirty rate will not be represented in our database. So that is called consistency. That is, you have multiple queries in your transaction, right? And before you commit all of the queries, commit this transaction, all of them are considered to be dirty, right? Until you commit them. So the consistency means your database will not see those dirty rate. And isolation levels are some isolation levels like rate, unrepeatable rate, or unrepeatable rate, or repeatable rate. Those isolation levels, by setting them, you can change the how you gonna select the data. So, but we will talk it maybe in tomorrow's session, like what is specific for the each words. Like D is for durability. That is, you will store all your data in the disk, means you will persist your data. Otherwise, if you just store the data in the memory, whenever the database shut down, then all the data gone, right? But if you store in the disk, it provides you the durability, the data persistency. So diagram. So what do you mean by diagram? So you mean the tables or the relation? So can you explain more on what is the diagram you mentioned? Like, do you mean table or something like that? Yeah, right. We have to maintain, to carefully design the tables, and also like the relationship, to carefully design the relationship between the tables. Like if you have a poorly designed table, maybe you will spend a lot of time on the drawing query, or the query that in the future you will execute it if you poorly design the relationship between those tables. And also there are something called normalization, right? Normalization that is used to save the storage, like reduce the redundancy in your data. But actually nowadays, like normalization is kind of trade-off. Like it used the space to use the time to trade your space. Like because you separate your one table into multiple tables and keep maybe using foreign key or primary key to maintain the relationship between different tables. But when you're trying to retrieve data, you have to join the data, maybe join multiple tables back together. But actually join operation is very expensive. So maybe in the old days that the disk is very expensive, so we want to reduce the redundancy as much as possible. But nowadays, like when we're using NoSQL database, like using MongoDB, maybe the disk is very cheap. So the storage, the space complexity is not our first priority. So we can just store all the data in one table, and we do not consider about um, in the future we can no worries about the drawing operation, because drawing need a lot of time, because you have to join the data, fetch the data from different table, and merge them together. It's kind of time expensive. So you just compare to normalize them into different table, you just maintain them in one data, one documents records. So those are some design choice. And also, besides the relationship between the tables, when we use database, most of the case we are trying to search data from the database, right? So how can we speed up our search performance? Like, can we introduce something that can speed up our search operation. Otherwise, maybe when we try to search something, we need to scan the full table. But is there anything that can provide us the advantages that we do not need to search the whole table when we're trying to find some records? Like when we try to find the student with ID of 10, can we just use something to directly get this student's records rather than scan the whole table and then get the specific select is kind of keywords. So there is like one feature, yeah, index, right? So we can further introduce something called index. So the index is used to speed up our search, like the select query, those searching queries. So when we try to select or search data records, if we select on this maybe column very multiple times, frequently, constantly searching on some specific column, then we can make an index on this column. So in this case, we are trading our trading the time, trading the space with the time. Like we will use extra space to store the index, like using a B tree or B plus tree. And then whenever we try to search based on this column name, we can search in the B tree. So because we are using a like a search tree, it will have just the worst case is the length of the height of the tree, the searching time, right? So we can speed up our searching time. Um, but we are using extra space to store the index, like store the B tree or B plus tree. So it's kind of trade-off. You always have to make the choice between the trade-offs, like whether you consider about the space or consider about the time complexity. And also, but when you're using the B tree or B plus tree, actually you speed up your search performance. But if you poorly design the index, like when you say, oh, if the index is so good that it can speed up our search performance, and then we just add index to every column. But that is not the case, because one thing is that when you're creating index, you are using extra space to store the B tree or B plus tree, right? That is one of the disadvantage, extra space. And also it will slow down your insertion time for a little bit. Like every time when you try to insert a new record, you first have to insert it into the B tree, right? In order for future retrieval. So this by creating index, when you insert, you have to doing some operation on the B tree, like insert into the tree. So it will slow down your insertion time. So there's also some disadvantages of creating index. So when you are trying to design the index, you have to carefully um, carefully make choice, make decisions to whether I create index on this column or not. It's not always a good idea to create index on some columns. And also, um, we will, like you said previously, the select, that is the syntax of the query, right? So we also need like the queries to, we need a syntax, need a query to retrieve or operate on our database. Otherwise, we cannot even delete or insert or search data from the database, right? We have to have a unique syntax, have us define a query, like either we have join query or we have uh, uh, like those aggregation functions, those queries. So we need queries, and also if we make multiple requests on the same records, retrieving data from the disk is very time expensive, right? So is there any like architecture that we, or data, or not data structure, is there any architecture we can provide to speed our performance on repeating request? So do you have any idea? Like, can we add something that for the repeating request, we do not have to for each time retrieve it from the disk, but maybe we can store the recent querying results at some place. Storing procedure. Yeah, that should be one. Yep, that should be one answer. And also, um, when you talk about storing procedure, do you mean that it changed the query execution plan or something like that, or you change change the way you're storing data, or can you be more specific? Or function? You mean have some predefined function like those storing procedures, and then just invoke those functions in the SQL database, or something like that? Because I think I'm not very expert in SQL part, so you can be like a little bit more detail on this, like the storing procedure. Um, Actually, any detailed explanations on that? Uh, Actually, yeah, maybe I can Google it after this session by myself. Yeah, no worries. So actually, what I want to state is about the cache. Like if I have like multiple repeating requests, then you can use the cache to cache the recent queries, and then if you have other transaction trying to retrieve the same data, you can just retrieve it from the cache, right? You do not need to still retrieve it from the disk. So this is uh, the database using the cache to speed up the repeating request. And also, um, one thing that's because we have already talked about the cache, right? Also, we need a disk for the data persistency, for the data durability. Otherwise, you just store it in the memory. Then every time you flash your system go down, then all the things, all the data will vanish, right? So you will need a disk to keep the data persistency. And also, um, how can we like resolve the race condition? Like, do you know if we have multiple transactions working at the same time, is there anything can we use something to maybe avoid the race condition? Mm, like maybe we can use the same thing lock, right? We can use add lock to the records we're trying to retrieve. And also, if you set the isolation level to be serializable, then it automatically add lock um, to your database when one transaction is working on some records, and is preventing that the race condition between different transactions. So those are some properties, or I said some features that we need to develop our database. And for the next part in the session, let's just cover some basic SQL queries uh, syntax. So the first syntax I want to introduce is the select and from, right? Those are the most basic syntax that you will meet in your SQL queries. Like uh, first we're trying to use this human resource database, and let's just use the employee table as an example. So here I want to select all the data records in the employees table. So, oh, no, does it just go? Oh, sorry. I think this life cycle, this life cycle does not store the things that right. Just go. Yeah, I think cannot retrieve. Oh, that's too bad. So maybe let's just write some SQL queries down here. So like the first select statement. So we want to select all the records from the HR database and also the employees table, right? So here we use the asterisk to indicate that we want to select all the columns, all the rows. So you can do something like this. You select from HR.employees. Try to run it. You see this SQL query statement return us all the records from the database, HR employee database employees table. And also, besides selecting all of the columns, we can specify the column name that we want to select. Maybe in this case, the first name. Actually, the queries does not detect the lowercase or uppercase, so you can just use or lowercase or define. So you can do something like this from HR.employee. First name, last name, right? So now we just select these two columns. And let me think what other things I want to introduce. And also, you can create alias name for the columns or tables, right? As for example, you can just use fn, then it will change the alias name for in the return result side. So, or you can just do not use the as keywords. You can just directly write as this. Also, for the alias name for the tables, you cannot use as keywords. You can only just if you write it this, I think it should give you an error. We cannot use the as keywords for the alias name for creating alias name for the employees table. Let me check. You see, now it works. And also this as keywords is alternative. Maybe just for simplicity, just get rid of all the as keywords. You just use this way to create alias name. And also there's another syntax, like when we select all the employees, there is a salary column for all of the employees, right? So what if we want to select the employees only with salary that may be larger than 5K? So I want to select salary larger than 5K. So what we can do is we can use the where statement, like select, just borrow the things here. Where maybe I think, can I just use salary dot larger than 50,100 or yeah, this should work. And maybe also display the salary in order to make it more clear. Yep. See, now it only contains the salary that's larger than 5K. Yep. So this is the where statement. And also, I think we can, because I haven't write the SQL query for a while. Let me try to test it. Yep. You can also specify that this column is from which table, but for now we only have one table, so we use the alias name.salary to specify that the salary is from this table. And let me further write other things like called aggregation function. But does anyone know what is aggregation function? Any answer to this? Like, have you ever used any aggregation function when you write a SQL query? Yep, right. Max and min, and also other things like maybe average or count, things like that. I think there is something called average. Let me try it. So here, what we're gonna do is still using the select, and we will use the aggregation function to maybe to select the max salary from the employee table. Trying to run it. Yep. So it returns me the maximum salary from the employee table by using the aggregation function. So why it's called aggregation function is because you see previously we have multiple rows, but now it just aggregates into one rows. And let me also check whether there's something called average. Yep, it can count the average of our salary. And if you feel that this column name is not good, maybe you can create an alias name like average, something like this. I think this should work. Yep, it changed the alias name of the result site. And also, we can try to use something called select count. Maybe asterisk from HR.employee. So this will count how many rows that we have is 107. And there's a difference between like when we use the count to count how many rows of specific column, or if you use the asterisk, it just count all the rows. So there's a difference between that if you just count a specific column and also count asterisk. So let me first run this. That is the difference lies on the null value. So if you count specific column that have null values, then those null values will not be counted into the result. So let's just try this. So if we count this commission percentage column, you will see the difference. Employees. You see, it only returns 35. So, but when you try to count extra asterisk, it just count all the rows, even though there's null value maybe in some of the columns. It just count all the rows, the number of all the rows. But if you count specific column, it will not count the null value. See, this is difference between when you apply the count on specific column or apply it on the on the whole table records. And also, besides this, one thing that I will introduce is the subquery. So subquery is like you will have it's like a nested query. Like first you make a subquery, it returns you some result set, and then you can make select or other statements again on this returning result set. So the first result set will be considered as a subquery. So for example, if you have something called, let's first create it, the subquery. So the subquery just have the same syntax as the normal query. Maybe just borrow it. So like this, you have a I have created query, and to make it to be a subquery, let's just select based on this resulting set. So we can select maybe last name, but I've already created alias name. Maybe I can do it in this way from and use parentheses to wrap it. We can try to run it. You see, actually, if you want to try to select the salary, you cannot do that because the result set, you see, invalid identifier, because this subquery returning us a result set only contains the fn and ln column. So if we select other columns from this result set, it will not allow you to do that. So even you maybe, let me try, can we select last name, or because we have already created, yeah, because we have already created alias name. So now we can only use the alias name in the result set to make further query. Yeah, just something like this. This is called the subquery. Like you see, there is a subquery in our out query. So this is subquery, and by using the subquery, we can achieve some interesting things. Like we can select all the employee records with the highest salary. Like for example, previously when we used the where is it? Maybe here. When we use the max aggregation function, we try to run it. No. It return us the maximum salary itself, right? But what if we want the whole rows, all the records of this employee with max salary? What we can do is we can achieve this with the subquery, like maximum salary. We can select asterisk from which are the employee where the salary equals to, like, remember this query return us the maximum salary, the value of the maximum salary, right? So we can just do something like this. We can select the maximum salary from the employees, and where the salary equals to this maximum salary, we return this employee records. So if we run this, you see it returns the employee in the employees table who has a maximum salary. We return the whole rows of this record. And also, there's one thing that we can do is like it is a commonly asked interview question, that is to select the second highest salary. So how can we do that? We can still doing the similar thing, like using a subquery, like second highest salary. What we can do is we can select, we can use first using the, let me think about it. So there's a couple of ways. So one way is that if we only want to select the second highest salary itself, we can first get rid of, using subquery to get rid of the maximum salary. So the result set will be the all the records, but without the maximum salary records. And then we can select the maximum from the result set. It will give us the second highest salary, right? That idea is first get rid of the maximum salary from the um, original data sets, and then from the resulting set, it has already get rid of the maximum salary. So when we select the maximum again, it will give us the second highest salary. So here, what we're gonna do is maybe select the maximum salary from HR.employees table. Employees table. Where? So we want to select the maximum to of when we get rid of the maximum salary. So we can first here, or maybe let's just create an alias name here. So here we can call it salary less than the maximum salary. So here we use the subquery to select max salary from HR.employee. So here you see we are selecting the maximum salary, and we use the where clause to only maintain to search from the result from the set that do not contains this maximum salary, and then we select the max from the result set that only that get rid of the maximum salary. So when we run it, you can return us the second highest salary. So the idea is to get rid of the highest one, then select max again. So that is the one way to select the second highest salary. And also, there is another way to, what if we want to do something similar like this? We want to select the whole rows of the employees with second highest salary. That is, we can use something called rank, and maybe also called, we also have something called dense rank. The rank and dense rank are different. That the dense rank, as the name infers, it has the rank is continuous, is dense. So it's like if I have two students with um, let me think. If I have two students with maybe score 100, so these two students will have the same rank, both of rank one, the rank first, and the second highest score may be 98. If you use dense rank, this rank will be, the student will be ranked as 2. But if you just use the normal rank, then because there is two students that have higher score than the student, so it will have a rank of 3. So this is the difference between the rank and the dense rank. So the dense rank is have a continuous rank, right? And let me further introduce how can we like select the rank of the students, or not the student, from the employee. Like let's first introduce this rank to the result set, and then we can use the where statement to select who has a rank of 2. That will be much easier. So we can select asterisk, and also select the let me think, the dense rank. Maybe for now, let's just use the rank first. Use the rank over first we have to use the order by to order this to make the records to be ordered by the salary. So we can do something like ordered by salary using the descending order. So by salary, descending order as rank from maybe from the chart or employee. We try to run this first. I think. Let me check what's wrong here. Form keywords, not font. Is it because I missed something? Maybe like this. Order by salary, things like this. Let me try to test it. Oh, okay. So here, maybe we have to specify that this column is from range table. But because I'm not very familiar with the SQL queries, so yeah, I'm not sure 100% sure of the reason that why we need to specify the tables here. But yeah, we can use the rank to rank on the salary, and you see this result set will contains an extra rank column that rank all the records based on the salary. And you see this is not a dense rank, right? This have two employees with 17K, 17K, and the fourth one will just be ranked as 4. But if we use the dense rank, you can see the fourth one will be ranked as 3. So you see the rank is continuous. 1, 2, 3, 4, 5. There is no missing rank. But if we're just using a rank, there will be some missing rank, like missing the rank 3. So based on this, we can make it as a result set. We can select extras from this, and also what we can do is select where the rank equals to, oh no, not equals to, just equals to 2. So this should be return us the employee with the second highest salary. Let me try to run this. You see, there are 2 employees with second highest salary, that of 17K. This is the subquery and also the rank statement that you use to achieve the second highest salary query. And also for this order by, let me further give another example, maybe if just to introduce the order by here, maybe kind of misleading. So the order by is the statement that you will order your sort your records based on some columns, like select asterisk from HR.employee, order by salary. And also you can specify that which order you want to use, whether descending or ascending. You can try to run this. You see, your data records is sort based on the ascending order. So you see the salary is increasing. And if you're using the descending order. Now the records is sort based on the descending order. And also after you sort it, you can make rank over this sorted result. Like this syntax, rank over ordered by salary dot descending order. So this is descending order and they're all ranked over it. So it will be the first rank, second rank, also the second rank, and so on and so forth. So this is the order by and rank syntax. I think this will be all for today's session. And do you have any questions related to this part? Like any queries you are not comfortable with, you can ask me. And if no other questions, then we can stop here and we will meet tomorrow at the same time. Yep. So if you do not have questions, you can feel free to leave. You can feel free to leave the meeting for now. Bye. See you guys. Thank you. Bye. Could you share the script and the database schema? Oh, those schema are like, oh, no. Oh, shit. Oh, it go back. Yep. Let me copy paste those things.